Welcome back, everybody. This is going to be part 1 of 5 on my video series on functions. Let's get started. A relation is any rule that relates a set of inputs. That set of inputs is what we call the domain to a set of outputs, and we call that set of outputs the range. Below, I have a picture of a couple of relations, and I would like you guys to find the domain and range of each of the following. Now, when we graph things, inputs are the x values, and outputs are the y. That came out weird. The y values. So the domain is the set of all x values that show up in the picture. So I like to think about it as if I pass a vertical line over the function where, or over the graph of the relation, where am I hitting the graph? So notice here, I start hitting it at -2, and -2 is included. And I keep going up until here. Remember, those open circles mean that it's not actually on the graph. So there are no points there. So let me write that info down. I've got -2 to 0, including -2, but not 0. Now let's keep going. Starting from 0, I immediately pick back up again, and I keep going until 3, and that would be the end of the function. So I also have 0 to 3, including 3, but not 0. That would be the domain. The range is the same idea, but it's the y values. So I look at a horizontal line. So here, starting at -2, I'm almost hitting the function, except that that point's not included. It's going to be just past there. And moving up, I notice at 0, I am still on the picture of the relation, right? On that graph. I just jump over to the left, and then I come up to 2, where I'm no longer on the picture. So all of the points between -2 and 2 are in the range, except not including those two. Part B is a little bit trickier. Notice I've got these arrows here. When you see an arrow like that, that means this pattern continues forever. So when I look at the domain, all of the points out to the left of this picture are still on the picture of the relation. So they're all included, all included. Here I have to think about it for a second, but notice I've got this closed circle up top, so it's still part of the domain. And then I keep going forever and ever. It looks like all real numbers are included, or in interval notation, -infinity to infinity. For the range, similarly, everything below this picture is going to be included, and I know that based on this arrow down at the bottom. But as I move closer to the top, I stop here at around 1.5. So the range is going to be everything from -infinity up to 1.5 or 3/2, including the 3/2. So you're probably wondering, great, well, you said this video was on functions, but we're talking about relations. What's the difference? Well, a function is a special kind of relation that assigns at most one output to every input. And typically we're used to seeing this in the context of numbers, but a relation just relates inputs to outputs. So it could be something like part A. Even numbers are blue and odd numbers are red. For each input being a number, does this assign at most one output? Well, yes, because no numbers are both even and odd. If I take a number, say 2, it's even, so it becomes blue. And it's not ever going to be red, right? So this assigns at most one color to each number. But things like pi that are neither even nor odd don't get an output, right? They don't have a color assigned to them. So at most 1. 0 is okay. It is okay for a number not to be assigned an output. So this one is a function. Let's look at this relationship below. Why don't you pause the video here to see if you can determine whether it's a function on your own. I think this one is a function. Notice for each unique input, in this case I don't repeat any inputs, I have at most 1 output. So this is a function. How about part C? Is this a function? Well, this one's a little bit more complicated to tell. We might need to use another tool. That's where the vertical line test comes in handy. The vertical line test is a way that we can determine whether a relationship is a function based on the sketch of its graph. If you can pass a vertical line across the graph of a relation without it touching the line in more than one place, it's a function. Let's look at part A. And let me grab a vertical line. In part A, notice as I move from left to right across the graph, my vertical line never touches the graph in more than one place. So this passes the vertical line test, and it's a function. And just to be extra clear, by vertical line test. Let's try the next one. Now, at this point, everything's fine. I'm touching the graph in exactly one place, but the second I move past there, now I'm touching the graph in multiple places. There. Oh, and there. Now, why does this mean it's not a function? Well, for this input value, it looks like I'm at about -1.5. I have 2 outputs. That's what the vertical line test was telling me. So this one is not a function, according to the vertical line test. Let's go back to this problem now. Why don't you pause the video here and see if you can use the vertical line test to determine whether this is a function or not. Remember, that requires sketching its graph function. I plotted a couple of points here by writing out a table, and I saw that I get a straight line. Sketching the graph of that, I see that it does pass the vertical line test, so it is a function. It's also possible to tell whether something is a function without ever sketching its graph. Typically, the way that we do this is we want to solve for our output variable. So in this relation, I would solve for y by subtracting x from both sides to get y equals 16 minus x. Now, all I need to do is plug in an input to see what kind of output I get. If I plug in 0, for example, because that's typically an easier number to plug in, I get 16, just one output. Turns out that regardless of which input I put in, I only get one output. So this one is a function. But let's take a look at the next one. Here, I would move my x squared over to the other side. And now I need to take the square root on both sides. So I get y equals, by my square root property, plus or minus the square root of 16 minus x squared. Now when I plug in 0, I will get y equals plus or minus the square root of 16 minus 0. That leaves me with just 16 on the inside. So y equals plus or minus 4. Notice here I got 2 outputs. So this one is not a function. All it takes is for one point to mess it up. So this is sufficient to show. Go ahead and pause the video here to see if you can do part C on your own. I found that this is a function. Notice, without having the y squared, I don't get that plus or minus business, so everything ends up being okay. In general, this is a general note, plus or minus means no function. Plus or minus typically means it's not a function. In this video, we saw what a function really is. Remember that it's a relation where each input gets assigned no more than one output. In the next video, we're going to take a look at some notation that's a little bit tricky to use, but that is going to be really important for the rest of our class. Catch y'all in the next one.